Good morning, my name is Lorna. I'm a developer advocate with IBM. I think advocacy is a relatively new thing, and I've already had lots of questions about what that means. And really it's about two things. One thing is telling you about cool things IBM does, which is really easy because it's mostly open source, so I can just be like, hey, RabbitMQ, and there's like a link on the last slide to IBM's cloud. So if you didn't know, IBM has a cloud. You can run your PHP applications there, and RabbitMQ is available. And now you know that, I've basically done my job, and we can concentrate on the interesting stuff. The other thing I do is I hear the things that you tell me and the questions that you ask, and I go back to work and I get those things changed. I fix the documentation, I fix the libraries, I lobby for the product changes that you need, I explain that the parameters are in the wrong format, and all those kinds of things. So it sort of works both ways, and along the way, I write a lot of content. I also write quite a lot of code. If you ask Stack Overflow questions related to the IBM Cloud, you are likely to get me, and sometimes I speak at conferences in between all that. So today I'm going to be talking about queues. My examples are specifically about RabbitMQ, but I'm going to try and give a nod to the other queuing tools that are available. I've used a bunch of different ones, and I think there's a lot of transferable ideas between the different queue offerings. So this is not... I am a RabbitMQ fangirl, but really I just love queues in general, so we'll try and mix that up. Let's start by talking about why I am so excited about queues, which are basically quite a boring and simple idea. I really like queues because they allow us to give our application superpowers. So we can take quite a dull application, perhaps quite an old one, and give it new abilities, particularly new scaling abilities, by adding a queue. And I've put here, you can asynchronously process tasks. I don't think anyone is sending email in the middle of their PHP script. If you are, don't tell me, because I'm no longer a consultant. I don't have to worry about these things. But things like processing uploads, formatting videos, there's a reason that the image thumbnailing is always the classic example. It's quite a good example of something that needs doing soonish, after we realize it needs doing, but not necessarily in real time, and certainly not while the user is waiting. There's a clue here. You can add asynchronous processing in your existing application. And this is one of the things I like most about queues, is you can use this technology in an existing application, in a legacy application. You don't need to wait for a new project to try this, to take advantage of it. And you don't need to remove something. It's not like saying, Postgres is awesome. By the way, Postgres, really, yes, is awesome. But to use Postgres, you need to take out MySQL, use Postgres instead. And that's awkward on an existing project, so you probably need to wait for the next new one. Queues are not like that. You can retrofit them. So queues are, particularly as we start to build web applications that are more than websites. We're doing more than this. Here is a picture of my cat, right? We are building PHP things today that are e-commerce, complex applications. Sometimes they're entirely back-end, running whole businesses. And when we build applications like that, we need to react to the events in those applications. And we need to scale up more than just rendering web pages. The queues allow us to do that by allowing different components in the system to scale up independently, and by providing a loose coupling point, a place where two parts of the system, or your system and a third-party API, can communicate in a way that isn't rigidly tied together. It can also be useful to integrate different parts of the system that might be written by different teams. All you need to do is agree on what the data format in the queue message should be. Those things can even be written in different technologies because every technology is able to write to the queue. The queue is like a database. It doesn't care what language you're using. There's nothing proprietary. And so you would be able to talk to those queues, both to write and to read messages from different tech stacks. So if you need to write one thing in a different language because there's a great library in that language, the queue will also help you there. I mentioned we're going to speak mostly about RabbitMQ today, so those are today's examples. RabbitMQ is a lightweight open source project. It's actually written in Erlang. It is as solid as a rock, which is why I like it. RabbitMQ is very powerful, very flexible. I would say it is not necessarily the easiest of the queue tools to begin with. So it doesn't have the easiest learning curve, but it has the most powerful features. Some other tools here that you may have heard of, and I'm often asked about the differences, so let's try and cover that up front. I have Gearman, which is specifically a job queue. So RabbitMQ is more like a message queue. Gearman is specifically a job queue. Today, my examples are all about task queues, job queues. So Gearman would work just as well in all my examples today, and I have used that before. I really like Beanstalk-D. It's also open source, even, I would say, definitely more lightweight than RabbitMQ. Simpler. It'll cover a lot of your use cases. Beanstalk has, saved me on a few occasions where the queue protected us from a large burst of unexpected traffic. I used to work on a system which was it was to do with smart energy metering. So lots and lots and lots of sensors, and they would build a new block of flats, a whole building full of apartments full of sensors. And then they would turn it on. And every single one of those sensors would instantly phone home, all at once. And before we had the queue, the server used to just fall over. And once we introduced the queue, that was okay. The queue would get pretty full. It would take, half an hour to process when we did that big reboot of a whole building. But the queues give you that ability to smooth out the burstiness of the internet, because when we say, oh yeah, we're doing 100 requests a second, they don't all come in nicely spaced over that second, and it's not the same in every second. We know that it tends to be very jaggedy when we're under load. Kafka, I think, is an awesome tool, but a bit different to what I'm talking about today. So Kafka is more of a message queue. You put messages on the queue, you attach a consumer, it processes the messages. Later, you can attach another consumer and reprocess those messages for different purposes, to check that all your transactions balance or to analyze a different report. Also, the messages will usually come through in batches on Kafka because it's very much aimed at sort of data streaming. So while I do use Kafka as well, and I like it, it's a little bit distinct to the examples that I'm giving today. I have Redis on this list. Okay, so Redis has, I love Redis, but has really, really basic queuing functionality. Really basic queuing functionality, but you probably already have Redis in your stack. So if you need to solve a problem like tomorrow, without introducing new dependencies and needing to get all of that agreed and signed off and deployed and whatever, you can go in the very short term, you can go to Redis to give you a little bit of queuing to solve the problem tomorrow, maybe ramp up to Beanstalk or RabbitMQ next month when you've had a bit more chance. Just wrap your queue class really abstractly. Is that a word? I'm English, so I guess I get to make the rules. Just wrap that queue class and switch out the back end if you outgrow Redis. If you know that you just need a small, simple queue, you'll probably live with Redis for quite a long time. Okay, Lorna, concentrate. RabbitMQ. Okay, so if you are going to run your own RabbitMQ, then you need to know that it has an awesome RabbitMQ management plugin, which gives you this nice web front end. So you can very easily see the size of the queues. You can see how quickly messages are arriving and being processed. You can also, there's some like manual tools here. You can like add messages to queues and inspect what's there. So there are some nice features, and this can be quite helpful. Particularly, I use this mostly when I'm developing, like just working on something and checking that things look like I expect them to look. There's also the RabbitMQ CTL tool, which I use more from the command line. So, as with all shiny technologies, there are some big words that I'll be using in this talk. So I thought we would begin by talking about some of those words so that you're familiar with them and they are no longer big or mysterious. The broker, you'll hear message broker. That's just the RabbitMQ installation. Within the RabbitMQ server, within the broker, we have multiple, or can have multiple exchanges. So when we send a message to RabbitMQ, we send it to a specific exchange with some information about how this message should be routed. And the queues are attached to exchanges. So you'll have these little nodes, exchanges, each have some queues attached. I've got the word queue here. Hopefully you're all familiar with that one. The binding key, so I have binding key and routing key. And hopefully I won't mix them up, but sometimes that happens. I have the binding key. These are the rules for, I made this queue. It belongs to this exchange. Messages matching this pattern should go into this queue. And a message might go into more than one queue if it matches more than one pattern of binding key. I have an example of that later, so hopefully this will make more sense with the diagram. We've got the message. The message is just the data that we're going to process, and sometimes some metadata alongside that. We have the routing key. This is something that goes with the message. We send it to the exchange and say, route it like this, and supply the message. You'll also hear me say consumer or worker. These are the scripts that take the messages off the queue and do something useful with them. The rest is all preamble. It's all set up. Now the workers are, the clue is in the name, the things that do the actual work. So we've got exchanges, we've got queues, we've got messages, and there's a few different things that you might want to know about each of those. The exchanges are how we sort of separate our different areas in RabbitMQ. The messages, when we send a message, we send it to an exchange. And the exchange then takes care of taking that message and its routing information and getting it all to the correct queues. Be careful if you route to a queue. If you send a message with a routing key which routes it to nowhere in particular, RabbitMQ will indeed route your message to nowhere in particular. So that is worth knowing. There's no like, you can set up some catch places for it. They're called dead letter exchanges, but just be careful. We have different types of exchange in RabbitMQ. The first is the simplest. It's called the direct exchange. You set up an exchange and you create queues. With a direct exchange, the routing key matches the queue name. So you publish a message to an exchange with a routing key, and that's just specifying which queue it goes into. So that's a very simple starting point. And I probably recommend this when you're using it for the first time, or if you're very clear about every message should go into just one queue. The second type of exchange is a topic exchange. Now, this is something that I most commonly work with, and it allows us to put messages, send messages to exchanges, and route them according to a bunch of rules. So a message might end up in more than one queue. So you can have all of the messages going to an exchange. These ones are related to comments. These ones are related to uploads. These ones are related to profile changes. And we put all of the we copy all of the comment ones, which might be multiple queues, into a comment.wildcard queue so that we can keep all that information together. It's commonly used for particularly sort of auditing, logging, that kind of thing. And the fan-out exchange, where all of the queues that you bind to this type of exchange will get a copy of the message. So if you're doing pub/sub and you know your subscribers up front, that can be a really just an easy way to set up. Obviously, when you're adding and removing subscribers, you have to actually add and remove queues on RabbitMQ, which is a bit of an overhead, but I have seen use cases where that worked pretty well. I mentioned, first of all, the direct exchange, and on RabbitMQ, we have a default exchange, which is used in all of the Hello World examples, which is just a special case of a direct exchange. So the exchange has an empty string as its name, and whatever we specify as the routing key, that will match the queue name. I feel like I undersold the Hello World tutorials there. The RabbitMQ project itself has absolutely excellent tutorials, beginner tutorials, and then increasingly complicated tutorials. And they're all based around specific use cases, and they're available in all the different languages. So you can get a specific, this is how you do a two-step worker in PHP, and it'll show you with the most common PHP library and all the examples that you need to run it. So really excellent documentation, and it's very joined up across all the different languages and the different libraries. For a long time, the RabbitMQ project kind of provided all of the libraries, so they had sort of central control, and the upshot is great documentation, but it's all on the RabbitMQ site and nothing on the individual libraries' websites. That was exchanges. Let's talk about queues. You can bind queues to exchanges with binding keys. These can include wildcards, which is how you can catch. So that allows you to send messages with slightly different routing keys and either catch them all in one queue or change your setup later so they end up in different queues. You can make those decisions. Queues can also be marked as durable, so persistent. This is to do with whether or not you would like to lose data if the server restarts. A lot of the time, the default options on RabbitMQ, similar to Redis is another good example, where it's set for just raw performance, not necessarily reliability. If your application is like around social media messages and whether your friend of your sister liked your colleague's photo of his cat from 3 weeks ago, right, then it probably doesn't matter if we lose some messages on restart, like, if you're using queues in your ordering system, financial application, or, you know, something a bit more important, then you probably care more about the durability. There's a gotcha. The queue has to be marked as durable, and the message has to be marked as durable, and then it'll survive the restart. So just look out for that. You can set up queues to have a maximum length to stop things from growing completely out of control. Do keep an eye on the monitoring on the queues, but also with the maximum length, it means you can just dictate, there's just no point in having a queue longer than this because it takes too long to process, or we're going to run out of memory on the server. I consider this to be quite good practice. Set it nice and high, but it can be really helpful. Be careful with the maximum length setting. When your queue is full and a new message arrives, it will be accepted onto the queue. And the one that's been there the longest, that was just about to get processed, will be dropped. And that might not be what you were expecting. So just look, you have been warned. That has definitely burned me more than once. You can configure a queue with what we call a dead letter exchange. This is just another exchange on the RabbitMQ broker. And there's nothing special about this other exchange. It's just we put its name in a configuration setting on the queue. So messages that get dropped from the queue, perhaps because the queue was full, end up in the dead letter exchange. Rather than just being sent to dev null, That allows us to inspect what was there, have a look at whether that queue is growing very quickly, look at which messages end up there, and perhaps process them again later. Messages are essentially a string. They're really not very exciting. They're essentially a string. You will commonly see JSON here, but that's purely a convention. You can use whatever string-based data format makes sense to you. Now, if it's very large, then it's taking up resource on the server, and that might affect how many messages you can easily handle or how quickly you can handle those. But if you are doing slightly more serious data than social media, then perhaps JSON isn't appropriate. I've also seen XML if you need the data type information. But also remember with RabbitMQ, often this is a link between two components that are both owned by you or by other people in your organization. It's rare that you're publishing a queue to external consumers. So you have a bit more control over what you can do in terms of data format, and I do see the binary formats here, so something like Apache Thrift would be a perfectly good fit here. It tends to confuse third-party general public consumers, but if you are controlling both ends, there's no reason why you shouldn't adopt something like that. Just a bit more compact than XML and a little bit more specific than JSON. We can attach other metadata to our messages. So, for example, we can set the time to live. If you are sending a notification of your friend's sister liking your colleague's cat, does it make any sense to deliver that 10 minutes late? We've probably moved on. It's probably not important. So you can set the time to live, saying this is a real-time chat notification. It is valid for 60 seconds. If something happens, your queue is filling up, the consumers are not running for a few minutes, those messages that have been in the queue too long will tidy themselves up, which is brilliant. So the stuff that is still useful when we've had a problem and we're processing the messages 10 minutes late. The stuff that is still useful remains in the queue. Everything else will essentially self-destruct. It actually ends up on a dead letter queue. You can set the durability when you set the message. RabbitMQ also supports priorities. I tend to think that if you have different rules about processing messages, you probably should have those in different queues with dedicated worker resource. But if you find yourself in the situation where you need priorities, then they are available. All right, I feel like that's enough talk. I have some code for you. I'm going to show you two examples, one very simple one and one that's a bit more of an echo of a real-world problem, although I've tried to shrink it so it fits in my brain and on the slides. This is about the same sort of size. So I have published my slide deck if you want to have a look at, if it's easier for you to see the code in front of you. If I understand technology and time zones, then I've tweeted it from my Twitter account. If not, I guess I'll tweet it later. And the code is available on GitHub, so if you'd rather see it in context as opposed to how I chopped it to fit on slides without making the font tiny, then you're very, very welcome. For using Rabbit from PHP, we use this AMQP library. So AMQP is a queuing standard. It's implemented by other tools than RabbitMQ, but I think Rabbit's probably the most well-known. But it is standards compliant, plus a little bit of extra stuff. So you're going to compose or require this PHP AMQP lib. It does have a couple of dependencies, so you will need extensions BCMath and mbstring. You probably have at least one of these. They're not particularly exotic extensions, but that's just something to look out for. So for our first example, we're going to write some code that receives a webhook and writes the data to a queue to be processed later. And this is because we could be receiving bursts of webhooks, and what we want to do is receive the data, store it, and close the connection. And that allows the thing receiving the webhooks to keep on running, not get slower and slower and slower, and eventually just die, leaving the connections open. And then we'll process things later from that queue. So for this, I'm going to set up a webhook on GitHub. So this is just like a general, click the webhooks button in settings on your repo, put a URL of choice in here. Specify the content type. GitHub will send you a form post, but I find that a bit odd. So I'm working with JSON, because that's how I think webhooks work. Credit to GitHub, they also have this secret thing, which will give you like an HMAC signature. Most webhooks / IoT things will just happily send HTTP posts to your system. Most systems will just happily receive them. Please be careful out there. Just because it's shiny new Internet of Things doesn't mean that we can unlearn the lessons of working with HTTP over all of the years. Okay, so one more thing I want to mention here. When I do this and I'm testing locally, I use a tool called ngrok. This is really nothing to do with the talk, but I just wanted to tell you about this cool thing. So ngrok is a tool that you run locally. You just run the binary. I often run it like inside my virtual machine where all of my dev platform is. Run ngrok, it gives you a URL, and then anyone in the world can hit that URL and therefore tunnel into hitting your dev platform endpoint. Very useful for testing incoming webhooks, because you don't need to push your code to a public place where a URL can reach. It allows you to test things coming in to your platform. Cool. So that was a little shout out for ngrok. It has an amazing dashboard. So you just need to generate the correct webhook once, and then you can press the replay button in the dashboard while you figure out what your code should have done when it received that webhook. Very useful. I was a tangent. Okay, so obviously a planned tangent. I've got a slide about it. One of my favorite tools. All right. So the PHP producer, it's called a producer because it's going to put the messages onto the queue. We're going to receive the webhooks from GitHub and write to the queue. I have the line 1, vendor autoload, because I have that AMQP lib included. On line 2, I am reading the incoming data. It's not a form post, it's JSON. So you're going to read this php:// input string. That's the body of the request that arrived to PHP. You need to do the same thing when you're working with like put data. Anything where you need to read the body and it's not a straightforward post request with formatted data. I am JSON decoding it. I promise if you read the GitHub version, there's like actual checking that we got some data and that it decoded correctly, but I took it out to fit it on the slide. We connect to RabbitMQ. And this is a pretty straightforward AMQP stream connection. Rabbit, the library for Rabbit, has very good support. So if you need to also use SSL and certificates and those kinds of things, we have support for all that. It's not brilliantly well documented, but it is there. And this is all running on a VM. So it's just localhost, Rabbit's default port, which is 5672, and its default credentials, guest and guest. I keep all of my demo apps on local VMs using default credentials in the hope that that will help me to work a demo under pressure at some time. On line 7, we're asking the Rabbit client to give us a channel. This is both brilliant and really quite boring. So for each machine that connects to a Rabbit server, it will make one single connection and keep it open. Each individual process that needs to connect to that Rabbit will just use this shared connection, but we'll use a little slice of it. So we get this channel, and that's giving us a little bit of the TCP connection isolated from the other communication going over the same link. Told you it was boring. Okay, then we declare the queue. Now, this is just in case the queue doesn't exist. We declare it. We declare it with a name, a bunch of extra arguments. So the first one is passive, something you can use to check if the queue exists or not, which can sometimes be useful. The second one is durability. I think we have some exclusivity and some NOAC here. You would need to look that up. So we declare our queue and with a name. Then we create the message. I'm literally putting the data I received into the message. So I've used $input here. And I set this delivery mode too. That's the durability switch. Don't ask me why it's called that, it just is. This is how you make your message durable. I thought you might find it useful, so I've included it in my example in case you copy it. And then we publish, and we just publish our message. This is the default exchange that I mentioned earlier, so it has a blank string name. And then this is the routing information. But for the default exchange, which is a direct exchange, this will just be the queue name. We just declared the queue. So we didn't need to declare any bindings there. Hooray, there are messages on the queue. Let's process those. Yeah. Why do I decode the JSON and then use the input in the message? My guess is that I was debugging this, or that if you look in the GitHub example, it's a little bit more advanced than this, is my guess. I don't know what this is doing here. You're really wide awake. Now I'm quite scared. Okay. I mean, not all this wide awake, or I'm going to be like, oh, yeah. All right. So this example does not fit on one slide. So I've put the boring stuff on this slide and the interesting stuff on the next slide. We're going to connect to RabbitMQ, get a channel, declare the queue. Good. Now the interesting stuff. Now we're consuming things from the queue this time. So cunningly, we need to start kind of in the middle. And we're going to do, we got the channel, we're going to do basic consume, give the queue name, give the exchange name. And then this is the callback. So we're doing a basic consume, and when we consume, we do this. And then this line just gives me a bit of blocking code so that we're waiting for messages to arrive. When messages arrive, the callback gets called. Within my callback, now we're on line 1. Within my callback, we pull the data from the message, do whatever it is we're going to do, and then we ack the message. We acknowledge the message. We say, yes, I successfully processed this message. So we ask the message for its delivery information. This is like the message ID. And then we ack that, saying, I have successfully processed this message. So that's just a really simple example, and all I'm trying to show you here is it's not that hard from PHP. You very easily would add this into an existing application. A lot of the frameworks have wrapper libraries, but you don't really need them. The individual library is fairly straightforward. You're just going to put the connection details in your wherever you keep your config, and then access it from your code. Okay. Slightly more advanced example. And this is something where I want to just show you around. It's a sample application built from a real support ticket idea kind of thing. Again, the code's available on GitHub, so please feel free to go and dig around. Don't be too amused by the Node.js also hanging around in this PHP example. So it goes. It's a simple guestbook application. Now, here's the hard part. If you are not old enough in technical years, then you won't remember that time when we had guestbooks on our websites. So just in case this is you, there's a couple of horrible cultural references that require you to be quite old in technical years. Some of you, I think, qualify. Just in case. A simple guestbook application. It's literally, we didn't have registration or really dynamic forms at all. So you go to a nice hotel or holiday cottage, you will write down your name and where you're from and what you liked about the place. We had that on our websites with no authentication or validation at all. So this application is literally, you write your name and then you write a comment and that's it. Right? So everybody's with me. Inside the code, the process looks something like this. First of all, we validate the post request. So somebody filled in the form for the guest book, sends us a post request. We check that it looks vaguely sensible, and we save the data to the database. And this old school guest book application, that's all it did, and it returned information to the user. I am upgrading my guestbook application to offer webhook functionality, so I can receive real-time notifications, or nearly real-time notifications, of new comments on my web blog guestbook. And so to do that, I need to do something. After I've saved the data to the database, I need to do something to notify everybody that was interested in receiving a webhook. So one option for this sort of turquoise green colored box here is to get a list of who needs to be notified. And for each of the things in the list, notify and wait for a response, and notify the next one and wait for a response from that one, which, you know, probably would work if you only had 3 subscribers. Probably won't work if you have like 10,000. So, and the user definitely does not want to wait for PHP to make 10,000 individual webhook requests and wait for the responses in real time. Definitely not. So let me present an alternative approach which uses queues. So on the left, we have the website. That's our existing PHP code. And all that does is take the data of the new comment. So that's who made the comment, what the comment says, probably some timestamp information, and a list of who needs to be notified. Get that information, throw it on the queue in a single message, return to the user. So the website has saved the data to the database, ordered some webhooks, delegated that work, and then the user's experience continues. Meanwhile, back at the ranch, on the queue, we can work through processing these. So I have 2 queues. One is the message data. So something happened, the form was filled in, we have an event, it's got some data, and we have a worker that consumes this, and it transforms the list of webhooks and the data into one message on a different queue. So this worker is also creating messages. One message on a different queue for every webhook we need to send. This makes a series of independent units of work. This is the key to distributed systems. You must be able to break down the work that needs doing into independent units that can be scaled up horizontally. If you can't break the work down like this, you can't build a truly scalable distributed system. If I need to send 10,000 or 10 million webhooks, why 10 million people would be interested in my blog guest book is something we can talk about later. But imagine that I had to send that many webhooks. You don't want to do that in a loop. If it goes wrong in the middle, we're going to have no idea. So we're going to break this down into individual units of work. So these are on the second queue, and then you're going to have another worker that's going to do sending the webhook, waiting for the response, and perhaps giving some feedback to the original system about the webhooks being sent or not. So let's try and tie ourselves back to RabbitMQ and think about, if we were trying to achieve this sort of thing, how we would set up RabbitMQ to receive that. So I have an exchange, and I have 3 queues here. The first one, events v1, is where the comment and large list of webhooks will arrive in the first case. So for every comment that's filled in on the guest book, we'll get one message on the events queue. There's a worker on the events queue. It's going to create one message for each webhook and put the message data in that we need to send. So all of those many messages, assuming that I have a wildly popular guest book never mind. All those messages will end up here on the notifications queue. And we'll have a second worker that processes that notifications queue, sends the webhooks, and waits to see if they work or not. I've included some version information in these. You don't need this. But I once rescued myself from a really large problem using an approach like this. So I just thought I would leave it like this. This is how I normally name my queues as a result of having screwed up 2 or 3 different ways, actually, in the past. So this is just a little bit of wisdom. And what I'm trying to give you here is the idea that if you need to make a really breaking change to the data that's on the queues and write new workers, you just create a new queue with a new version number, send new message format with that routing key to get into that new queue, write new workers. You can deploy that immediately. Meanwhile, the V1 queues will just work down to empty. It's very, very difficult to step change deploy producers and consumers at the same time, and your queues will probably have things in. Seeing systems that like turn it off, have some downtime, throw away the data in the queues, I think we can do better than that. So this is one way that you might find useful. So it's just I didn't take it out in case it was useful. The dots in the routing keys are just a convention, but they're a widely recognized convention. So you'll have kind of major topic dot minor topic in the routing keys. What I've done here is they're all hooks dot something, and at the third queue is the logs queue. And hooks dot anything, that hash, or I think the Americans would say pound, symbol, is a wildcard that can include multiple segments. And so everything that comes into this exchange with a routing key of hooks.anything, I'm also writing it to my logs. So I can just log that I did receive it. So if we have something goes wrong, I can see, did the message not arrive on the exchange? Or did we not process it correctly? So every message that comes in will go to whichever queue it's for, and the message will be copied also to the logs queue, and they'll be processed independently. So this is a topic exchange. This isn't an unusual setup. And I think it's quite a nice, it's the most common use case I see of messages going to multiple endpoints. Let's talk a little bit about what happens after the messages are on the queue. Because RabbitMQ is, to talk about it, is about configuring it, writing to it, setting it up. But there's a lot, if you're going to work with queues in your applications, there are things I want you to know. Workers are disposable. You can throw them away. They have to work kind of on their own, in the dark, underground. They're not very user-facing. They're just a bunch of scripts running somewhere. So if something goes wrong and you can't figure it out, you're going to just exit. Ideally, you're going to actually detect the error and let the queue know there's a problem. I have a slide on retries in a minute. But don't try to limp along. You need to be really, really defensive. Did I receive data? Did I understand the data? Is the data something I can process? Is this any kind of valid? Okay, I've kind of touched on this with the IoT remarks. We need to be a little bit more paranoid than we often are about the data that we receive through this. This is basically user input. It comes off a queue, you don't know where it's been. So be paranoid when you pull data from a queue. Most of the time, it'll just be some sort of zombie sensor sending you an empty packet, right? It's not malicious, but it could be. So be careful. Like I say, most of the time. All of the problems are an empty packet. All of them. Be careful about long-running process hazards. Somebody will tell you that PHP is not the right language to write a worker script in, and I disagree. Respectfully, but loudly. There's no reason you shouldn't write workers that run for days on end in PHP. But there are some things to look out for. Because when we write PHP for the web, we get a fresh, isolated request, when a fresh, isolated kind of runtime, when the request comes in, and then when it's finished, it kind of tidies itself up, and it never contaminates any other request. It's just the way that we're accustomed to work. So there are some practices which are completely acceptable in web-based PHP that you are not going to do with a long-running process. In particular, we are guilty of completely failing to close resource handles, files, database connections. You need to close those. You also need to properly initialize everything because we're going to be running in a loop. So if you leave data in a variable, it could easily sneak into the next loop. Those are things you need to be careful about. Be really careful appending to an array or something, because that will just grow and grow and grow. Eventually, you'll run out of memory. So there are some things that you want to do differently for a long-running worker script. It's going to run in a loop and just keep on getting jobs and processing them. Another thing to be careful of is that typically we set up RabbitMQ to have what we call at least once delivery. The message goes on the queue. A worker picks it up. If that worker exits without sending us the ACK, without acknowledging it was successfully processed, we give the job to someone else. If it was successfully processed and we just lost the ACK, it's going to get processed twice. So your application needs to be able to handle duplicates, because that will happen, rarely, but it will happen. So yes, things might get processed more than once, and by definition, things will get processed out of order. Because we're going to have 24 workers consuming your queue. So if you put 50 jobs in, they're all going to the first half are probably going to complete before the second half, but that's all I can tell you. If it matters what order your messages are processed in, then they are not independent and you have not built a scalable system. If you need to process things in batches together, then keep them together. Process them in batches. They're not independent. If they can be independent, it doesn't matter what order they go in. So just look out for that. So we create workers, and we need to skill them up, send them out, and they need to know what to do independently in the face of any adversity. You can think of them like lemmings. Here's another one of those cultural age-specific questions. This is a computer game. If you don't remember, right? These little critters are called lemmings, and they all follow one another. And what you do is you just let them all out. They all follow one another. If they come to an edge of a cliff, they just all follow each other off the edge of the cliff, which is what real-life little cuddly lemmings are famous for. But you can teach them skills. You can teach them to build sets of steps like this, or to tunnel through barriers like this. So you skill up your little guys, and you send them out into the dark to make their own way independently. And it's just like writing workers. You give them some skills, teach them what to do in the moment of adversity, make sure they have great logging, show them what to do, and then send them out. And then they find their own way. And that's the closest parallel I can think of for writing really excellent workers. Awesome logging needs to be aggregated. You should not be logging into servers to check logs from multiple different workers. So write the logs, but ship them somewhere central where you can very easily see, oh, we got a lot of this error message all of a sudden. And you can also see all of the worker logs in context together. There are some things I particularly like to monitor. Queue size is a good one. Try not to get paged at 4 o'clock in the morning. There's 1 million items in the queue. Or maybe that's normal for 4 o'clock in the morning. You need to know that. So have an idea of how big your queue is usually. Is it growing very quickly? Is it growing a bit every day over time? That's a problem. It's fine for it to get big and then get small. But if it gets big and then gets bigger, you probably have a problem. I like to have worker uptime. The workers will be being looked after by I'm trying not to say supervisor process because that's the name of the software. Some sort of process that will make sure we have the right number of workers running all the time. Supervisor D is a good one. I see a lot of system D setups now as well. So you're going to say, right, run this script, I want 8 of them. And if one of them dies, it will restart it. It makes it safe to exit. It also means you should be able to track the uptime of your workers. And I often see workers that automatically restart themselves after a certain amount of time. So maybe they process 10,000 jobs and then they restart. If that restart is usually every 18 hours and suddenly becomes 18 seconds after a deploy, yeah, you should worry about that. But crucially, you should know that. You should have the insight for that. If you just automate, if it dies, restart, you can miss the subtleties of what is going on. Because it's so hard to inspect when you've just sent this large number of small animals out into the dark. Keep an eye on how long each type of message takes to be processed. There's the obvious risks. You do a deployment and then everything takes a bit longer. You probably introduce some sort of inefficiency. Keep an eye on that because it's really hard to optimize this stuff. Maybe you didn't do a deployment and everything got a lot slower. My money's on DNS timeout. But a bunch of things could happen. It's important that you realize, because otherwise you'll find your queue gets bigger, you need to add some more resource in the short term while you figure it out. Keep an eye on those. If your processing time gets mysteriously shorter when you didn't expect it to, then you should really, really worry. That's the worst problem I've ever seen, is the thing just started acting without actually processing the work. That's when you should panic. Ship with as few dependencies as possible, minimum viable dependencies. Try not to write a worker that uses your whole full stack framework. You don't need most of it. Just try to be you should be writing small, focused workers. Just include what they need. When we do process a message, we can send the acknowledgement. We can also send not acknowledgement. We can reject instead of ack. And the reject means, nope, did not process this correctly. You can choose whether you should re-queue that message, in which case it goes back on the front of the queue, it gets processed again immediately, or not. Be really careful re-queuing messages. If you couldn't process it once, maybe it's because a third-party API failed and a retry will do the job. Maybe something went wrong with the worker and a fresh worker will help. Maybe this message can't be processed. If you keep on re-queuing it, we're going to spend a lot of resource queuing and re-queuing this message. And you get a poison message, which you just try and reprocess lots of times. Yes, question. Does the message know that it wasn't acknowledged? No, the message doesn't change. They're immutable. So if you want to do something like that, just bear with me. I have a retry slide in about 2 slides. Yes, come in. I can see it. Oh. So you can reject it without the re-queue. If you have the dead letter exchange set up, your message will go there instead. If your message is on the queue for too long, it exceeds its time to live, it will go also to the dead letter exchange. And if the queue was too long and one of the messages got dropped, that message also goes to the dead letter exchange. So once things end up in the queues on our dead letter exchange, we have a choice of options. We can look and see which edge cases are not being caught. Also, if the problem was third-party API went down for 2 hours and everything ended up on the dead letter exchange, once that third-party API is back up, we can write a worker that reads the messages and recreates them and reprocesses them. The data is not lost because we've caught it somewhere and we're dealing with it. What Rabbit doesn't have is any way of retrying, of having a concept of this, that we've already had a problem with this message. It's not very hard to implement it by yourself. The most important thing you need to know is that the messages cannot be changed. So we can't add retry information to our RabbitMQ message. What we do is, the message is on the queue, the worker tries to process it. We can't process it. Okay. So we make a new message identical to the old one, because we can't change the old one. We add we've already tried this once, data, and we put it back on the back of the queue, and we mark that first message as successfully processed. You might want to write some logs somewhere that let you know that there were some retries. A lot of the time, the difference between this manual create new message, put it back on the back of the queue, and the reject with re-queue, which puts the same message back on the front of the queue, the big difference is maybe it takes half a second for all the other messages in the queue to get processed. And whatever that glitch was, just caused you to fail, will be gone in half a second. So often, just put it on the back of the queue. Things don't get stuck behind it because the rest of the queue drains down. Then you reprocess. That's given me a lot of luck, actually, that there's just enough back off to let things suddenly pull themselves together. If you get a message which already has "we are retrying this message" in it, again, create a new message, copy it over, increment the retry counter, and don't keep on retrying. So if you get to 3 attempts or 5 attempts, whatever makes sense in your scenario, then stop there. And otherwise, you can get, if you just blindly re-queue all the time, you get poison messages, which will clog up your queue. You will spend a lot of resource on the worker side, trying to process lots and lots of messages that can never be processed, and the real work won't get done. Your queue usually backs up horribly. You can also do some back-off time. Rabbit doesn't have that built in, so you're going to build special queues that are executed at special times. It's not very straightforward, but you can do it. I also want to mention the feedback mechanisms. I think this is something that we have a lot of anxiety about when we're so accustomed to writing synchronous code. The idea is that you put a job on the queue and then we're done. Right, the work gets done and the original application shouldn't care. Often, the original application does need to care because this is the real world and we don't all write ideal academic distributed systems, although that would be lovely. Often, the original system does need some sort of feedback. So like the user uploaded an avatar, and we're going to show them cogs for a while. When we have finished thumbnailing, we do want to update what they're seeing. So for that, what we usually do is we add an additional queue to offer some feedback to the original system. So here's the webhooks setup again with events and notifications and that catch all logs queue. When we successfully process a webhook, we can give that information back to the calling application. So we have an outcomes exchange and this additional status queue. So that second worker is going to write new messages to this other queue, and the first application is going to consume this to get the information in. So we're using it as two-way communication in the queues. We make another queue that's consumed by the original application to get updates on what's happening. Queues in general, I think, are a cornerstone of today's applications. I think they give us some very important tools for modern applications, for building in an increasingly modular manner, for communicating between multiple applications. They allow us to scale. They allow us to be resilient. If one system is being a little bit flaky, the queues kind of protect us from the burstiness and also from the failure. They can buffer work that needs doing. They allow us to scale our systems and scale each platform independently. You've seen I had 2 or 3 different workers in that setup. If one of the queues is getting too big, I only need more of that worker. I don't need to deploy a whole new webhead every time because we're being very targeted about the work that we do. I used RabbitMQ as my example. We have it on the IBM platform. That's not the only reason. That's not the only reason. It's not really a hardship. It's always been one of my favorite tools. And now I have it available to play with on my cloud where someone else pays my hosting bills. That's quite excellent. And I also gave a little shout out at the beginning to the other queue tools. I don't want you to rush back to the office tomorrow or next week and rip out what you already have if it's a different queue system. Most of what I've showed you here is in some way transferable or implementable in other systems. So I have like 1 minute for questions, 2 minutes for questions, and I have some resources for you. So there's the RabbitMQ's landing page. You can also try it on IBM's cloud. We have a free trial, so sign up when you have time to make best use of the 30 days. And if you have questions, I can answer those. I write quite a lot about this, and I also collect all of my slide decks and articles in other places, such as on my work blog, onto my blog. So lornajane.net is a place to go if you're interested in this kind of stuff. There's the code link to that guest book Webhooks app that I showed. That's probably got the best of the PHP RabbitMQ examples in that you might like to look at. And finally, here are my contact details. Who has a question for me? Yeah.
As far as I understand, it's possible to have several exchanges in one system. And each exchange can have several queues.
Yes.
What is your recommendation when you have to split it on queue level and on exchange level?
Okay, this is a really good question. Within a RabbitMQ server, you can have multiple exchanges. Each exchange has multiple queues. What's my advice for architecting this? Try to give a new exchange for each component. RabbitMQ actually supports something called vhosts, which I didn't get into today, but put your exchange on independent vhosts if you think that you might possibly outgrow or want to move these systems in future, because it's very easy to move vhosts between hosts. So within that, an exchange per kind of group of things. So the 2-step worker processing the webhooks, I put that on a single exchange, but the feedback mechanism, which will be consumed by something else, was on a different exchange. if you are in doubt about whether you need a new queue, put it in a new queue. Always put it in a new queue. This has saved me so many times. I had one where I had more or less the same data arriving from 3 different suppliers, actually all those queues processed by the same workers. I put it in 3 different queues, and the day that one of those suppliers sent me utter nonsense, it didn't take out the other 2 queues. So there was no real reason for using separate queues, but now I'm a convert. Always use more queues, because if there's a problem, if there's anything different, any reason to separate them, a bug could affect just one, and then it's isolated, and it doesn't take out your whole system. Whereas if you've got messages choking the workers and all of your good messages are also in the same queue, you have no choices. Similarly with the routing naming, I quite often have a queue that catches them all with a bit of a wildcard, and that gives you the option to separate out later. Does that answer your question? Fantastic. I can't really take one more, I'm out of time. Okay, listen, I am around all day today and tomorrow when I'm speaking about serverless JavaScript. I hardly know anyone, so I am super happy to stop and chat about technology. Thanks for joining me so early in the morning.